So hello, and I guess thank you for having me. It's great to kind of speak at these meetup events. Um, so my name is Christopher Chalcraft. I'm a solutions architect at Databricks. I have about 10 years of oil and gas energy experience. I started in seismic data processing, geophysical software development, and then data science at Chevron, and now currently at Databricks. And so what I'm going to talk about today is building a lakehouse. And so, I know not a lot of people will be familiar with the term lakehouse. I was just going to show that, there was a paper that was published this year by a lot of the co-founders of Databricks. And, this paper was published like January 11th, 2021. And it was kind of like, next generation data warehousing and analytics. And so I'm going to talk about kind of like bringing those two worlds together, like the data lake and trying to fix some of the flaws that we see in that kind of data management paradigm, and how we can leverage some of the things that we love about data warehouses, concurrency, low latency, and then a lot of the different dashboarding capabilities. So I guess a little bit about Databricks. Oh, sorry, I'm not sharing my screen here. So a little bit about Databricks. So it's a unified data analytics platform. A lot of the co-founders of Spark were the ones who started Databricks, I think around 2015. And since then, we've seen a lot of adoption in terms of customers, different partners, and a lot of people are kind of picking up the platform for kind of unifying their data analytics teams. Some of the technology that I've listed here, there's like Spark, for a lot of the big data and parallel processing. Delta, which is a file format that's based on Parquet. And I'm going to talk about that today and kind of how that ties into the lakehouse strategy and having some kind of underlying transactional layer of your data lake. Some of the other technologies are MLflow. We're not really going to discuss on that, MLflow and Koalas. But then also there's Redash, which is something that we've acquired for SQL Analytics. So just like a little bit of transition. I kind of went through this a little bit, but yeah. So I'm going to talk about Delta, and then one other thing specifically is called Photon. And so one of the issues that we have in terms of building business BI dashboards and reporting off of the data lake is that you have like really poor performance. And so Databricks has developed something called Photon, which is a vectorized execution engine. Essentially, it's just like Spark, highly optimized and rewritten in a lower level language to help speed up and address some of those issues. So the key things to focus on here are Delta and how we are going to, I'm going to tell you about the format and why it helps bring a lot of structure to the data lake, and then Photon, how we can then speed up our queries and make our data lake data warehouse like, where we can have that kind of BI capabilities. I suppose I will hold questions till the end, just in interest of time. Okay, so introduction to Lakehouse. So all companies want to create valuable business insight, and they want to have data being a core piece of their of that decision-making process, right? The end goal is not necessarily to just move data around or, promote models to production or some fancy DevOps process. But it's really about that kind of that high impact data-driven decisions. And so there are a lot of different blueprints that data engineers and data scientists might use, on how the data is ingested, how it's accessed, and the way that the data is organized really governs kind of how the whole team works with it and ultimately defines how useful that data is. So we're going to look at two historically dominant architectures. We're going to look at first data warehouse, some of the advantages, the disadvantages, the data lakes, the same thing, and then kind of how we can bring them together in the what do you call it, like the paradigm that we call Lakehouse. So for data warehouses, no doubt they're amazing and they're purpose-built, for BI and reporting. And I mean, it's excellent in terms of for semi-structured, structured data and able to handle that kind of high concurrency, low latency workloads that you need for that BI and reporting. But you do run into some issues, some being no support for like this unstructured data that's becoming more and more prevalent in our world today, which might limit some ML data science type workflows. And then there's limited support for real-time streaming. So, I mean, you can do streaming like with Lambda or Kappa architectures. If you look at things like Stream Analytics with Synapse or Snowpipe with Snowflake, it's possible to do those things. But it's just not as easy as saying, let's just dump my data here and we'll worry about that downstream process later. So another issue is like you have these closed proprietary formats. So you kind of have this like lock-in. You're kind of like tied to this data warehouse, whether you want to be tied to a specific cloud. I know this is an Azure group, but like, we at Databricks, we find that like this hybrid cloud approach is becoming more and more prevalent these days. And so people want to have that flexibility of where their data is stored and how it can easily be moved around. Okay, so that's all I had on data warehouses. I kind of went a bit long there. Okay, so let's go on to data lakes. So data lakes, it's cheap storage on the cloud, and sorry, there's something going on outside. So it's a cloud object storage where you can store all your data. So if on Azure you have like ADLS Gen 2, where you have that combination of that binary large object storage with that hierarchical file system, where you have that multimodal approach. It's economical and it's good for data science and ML use cases, but they also have problems. Like there's very poor BI support to date. Like there are things like Starburst and what I'll show you later, like Databricks, we have SQL Analytics. But traditionally, there's poor BI support. They're complex to set up. And because you have that flexibility to do the kind of like dump and deal with it later, you end up with, just like too many files, and it doesn't really enable your data teams to work in in like a reliable way or an efficient way rather, because maybe when you're dealing with big data, it's kind of hard to just kind of take snippets of data and try to figure out what you're looking at. You kind of need to have a little bit more organization around how you structure your data lake and how you structure that hierarchy. So how do we get the best of both worlds? It's it can be a philosophical type question where which will kind of win out in the long term. But today, what we see, what I see, is a lot of people moving to this like hybrid approach, right, where you have a lot of data being ingested into the data lake, but then when you need those features, that structure around like the data warehouse, multiple users, then that data is being essentially moved and served into like a data warehouse. But so the Lakehouse aims to solve that. So how can we combine the best of the two? And we get those advantages of like decreasing the amount of complexity in our IT architecture, right? So we're not ingesting from a variety of SQL databases or different blob stores, kind of project specific. You kind of have that one underlying data lake for storage for both your structured, semi-structured, unstructured data, right? So there's a lot of flexibility in that in that camp. So, but then there's lower maintenance. It's better for cost because it's, cheap, redundant storage. And then what we're going to really focus on is how having all that data in one place makes your data teams more unified. And so you don't have to be copying data maybe from different systems back to the data lake to run some ML use case and then create a data product, serve it at some other SQL database where somebody is building reports. I mean, there's nothing wrong with that. We can argue different, or not argue, but we can propose different architectures, and everybody has to create architectures for their own specific use case. But definitely having one kind of single source of truth is something that a lot of people are striving towards, and making sure that you can see that data lineage and that data governance throughout your ETL pipelines. Okay, so building a lakehouse, what do we need? Let's go through it. So we have a data lake. We have data lake, so that's cloud storage, blob storage. We need a powerful engine enabled to make those queries performant against the data lake, and then the open source formats to allow that kind of transferability. So you can, so you're not necessarily locked into one thing. And then having a transactional layer to provide the consistency and the reliability to your data, and so that's where we're going to mention the Delta format. You need an ETL and data cleansing workflow, like how you are going to manage your data ops process, right? How are you going to promote a more refined version of the data or some kind of gold level table that you want to use for reporting? And then how well does it integrate with the other data teams that you have, whether they be somebody just writing queries that wants to maybe do some alerting or some quickie analysis, some BI dashboard tools, or ML and streaming use cases. So you want to make sure that it can handle all these kind of core concepts. So let's talk about Delta Lake. So I realize the terminology kind of gets confusing from time to time, and I actually struggle with it. It's you're having to deal with data lakes, data warehouses, lake houses, Delta Lake, Delt Engine. It can be a real challenge to keep up with the jargon. But essentially, when we talk about Delta Lake, we're just talking about a data lake that leverages the Delta format to provide some reliability and structure to your data lake. So the emergence of data lakes, or I guess rather why we choose the data lake as our one kind of source of truth, is that you have cheap, durable storage. You have the support, like we mentioned before, but support for all the video and the audio, structured and unstructured data, and then you have open and standardized formats. So Parquet, very common format in the big data ecosystem. Delta, it is based on Parquet with a transaction log. But then there are lots of different other types of formats like ORC or ORC and Avro. But you want to keep these standardized formats so you can always migrate to something else when the hottest new tool there is out or a different processing workflow. So what are the challenges with data lakes? Well, it's hard to append data. So when you have different streaming data, you have lots of different files coming in, and at the same time, you want to be able to read that data consistently, and that can lead to a lot of issues. then we have the modification of existing data can be difficult. So, sometimes you have to find ways of chunking your data. So if you do need to update or delete records, you can just go and kind of snip out whatever you need, versus kind of having to like reshard your entire data set or something like that, which could take days. So having that kind of like that fine granular ability to make modifications is really beneficial. And then jobs failing midway. So you go, you have some kind of streaming job, it might fail, the cluster goes down for whatever reason, and then you're trying to access the data and only half the data is there. So that's another issue. So you want to make sure that we address that. The mix of streaming and batch leads to inconsistencies. Like I mentioned before, you have like the Lambda and Kappa architectures, and these can, it can cause a lot of confusion and maybe a lot of like manual work that is unnecessary. And so kind of being able to address that mix of streaming and batch is something that is also desirable. It's costly to keep versions of the data. So, I mean, this kind of ties back into the being able to make edits with the data set. But, if you do need to go back for auditing or governance reasons, or perhaps if you maybe you wanted to use a specific version of the data for a data science or ML use case, it's kind of important to have that version control with your data. And then it's also difficult to handle metadata. So metadata can be, depending on the scale of your data, the metadata can be very large and difficult to manage, right? And so often you'll have like auxiliary databases that will hold metadata for enrichment purposes. But that can be difficult to manage, and it can lead to inconsistency issues. And also the size of it. Sorry, I'm going a little slow here, but so you have too many files problem. So this is when you have like reading millions of tiny files into your data lake, and this could have a large impact on performance. And so, how do you get that great performance? So you have different partitioning schemes, and being able to manually adjust your the type of compute you're using, the amount of cores, different runtimes, and creating all the different partition schemes, that can be quite an exhaustive manual effort and difficult to change for downstream processing. And then finally, just data quality issues, like you heard the term like data swamp being used here and there, but a lot of people, myself included, I had like a hard time like getting into using a data lake, because it honestly just seemed like a big mess of files, and like it was hard to navigate, hard to figure out like what was the data I needed, and how to kind of like pull it together. So definitely that lineage and governance issues. Hopefully, I guess Emerson might talk about that later. Okay, so now let's talk about how Delta is going to address that. So Delta, it's an open source format, so it's not specific to Databricks. Yes, Databricks did create it, but it is open source, backed by Databricks. So it's based on Parquet, and it has this transactional log that monitors different types of actions and transformations being applied to your data set, files being appended, different deletes and updates and what have you, as well as different checkpointing. So, and this is kind of like the underlying technology that we're going to use, that's going to be crucial for like applying to that structure to our data lake. Okay, so now let's take those 9 issues and let's see where Delta, how Delta addresses each of them. don't worry, like we're not gonna have to go through all like 9 because I think the first 5 are handled by ACID transactions. So ACID transactions, like atomicity, it's like how either your data succeeds being written or it's fully aborted for later retries. And so you can see kind of here, like this is kind of what you would see in a hierarchical database or a data lake structure, right? You'll have like a path to table, but then alongside that table, you'll have an underscore delta log where you have the different transactions recorded in JSON format, and then a checkpoint at a certain interval, which you can define. I think 10 is the default. So you have those ACID transactions, and so this is going to make it easy to. Oh, sorry. Hold on. Where am I going here? Easy to like append data, right? So you're adding files, and so those files, file 1.parquet, file 2.parquet, those are being tracked within your Delta log. If you want to make modifications to the existing data, because you have this transaction log at your disposal, you can go through and make those modifications at a more granular scale, and you don't have to worry about things failing halfway because it's ACID compliant. So this is a big one, and then yeah, so it's checkpointed at 10, and then it just keeps on going. Yes, you do have a lot of files like being built up. I mean, there are lots of advantages that I'll kind of or that I'll talk about later that are saved within the different JSON files in terms of column statistics and different types of performance optimizations that you can do at a later stage. Okay, so let's see, where am I here? Okay, so I mentioned this, either it fully succeeds or it doesn't. Yeah, so because we have this log, now our data is versioned. So we can go, we refer to it as time travel, but we can go back in time and revert to a previous version of our data. And it could be as simple as something like a select star from events timestamp or a specific version. So the versions, I think, will correspond kind of with those JSON files, like 0 and counting upwards, or if you have a timestamp index, you could refer to a timestamp. So that's nice, both in terms of if you make a mistake somewhere in your processing, you have to go back. That's not an issue, or for data science use cases, also useful. Okay, so now how do we handle the large metadata? Well, so Delta is based on Parquet, and it is compatible with Apache Spark. And so essentially, we use Spark under the hood for handling this like big data processing. You have the Delta caching, and then a lot of optimizations being that can be taken place. Like there's like a Delta auto optimize that you can run, which will do things like compaction or allow for file skipping. And then you have the metadata that coexists, so there's no need to keep that catalog in the data in sync. I think I already mentioned that, but so you don't have to worry about handling that large metadata because you have Spark, and then you also have the transaction log. Yeah, so the too many files problem. So this is common. Oh yeah, so I mean this is kind of where I should have mentioned that. So like you have the compaction being done, or you can run specific optimized commands like here, like optimize events on a Delta table, and what that'll do is it'll take a lot of the tiny files that you have and compress them into more manageable file sizes. There are different partitioning techniques that you can do based on either the layout of your data, or it could be some kind of statistical technique, right? Whether it's the things like Bloom filter for needle in the haystack type queries, or data skipping is, I think, probably the most important one. It's like, knowing different column statistics and being able to filter out 90% of your data or whatever, so you can just hone in on whatever your query is actually concerned about, is really big. And then with Spark 3.0, there's adaptive query execution, so that'll allow that to be handled kind of like behind the scenes, right? Rather than you having to manually manage that. There's something Z ordering, and that's a way for I guess allowing multiple columns to be optimized equally. So a very common one I see is like the year, month, day, right? To get similar performance on different types of queries for specific columns, or whatever it is that you're looking at, or whatever you're querying most often. Okay. So I can't tell how fast I'm speaking. It's only 4 o'clock, so I guess I have a lot of time. Sorry, it feels like I'm going too slow, but I guess not. Okay, so now in terms of data quality issues, we have things for like schema validation. So Delta will allow, or there are flags that you can set to enforce a schema, right? Which can be useful, if you want to maintain the quality of your data. But if the data changes over time, or different ways to deal with like merges and joins and stuff, you might want that ability to have that schema evolution. And that's just a flag that you can turn on and off. And so I've personally found this to be like one of the most useful aspects of the format, rather than having to like chunk data and deal with forward filling and backfilling type processes. You can just use like really simple merge into SQL commands, on specific column IDs, and then you could do a when matched update and when not matched insert. Right. And so like those types of merge commands really simplify like your mix of streaming and batch data, is where I've personally seen it used quite heavily. But just in general, like whenever you're kind of merging data together, you can have this flexibility to manipulate your data. Okay, so hopefully that gave a good overview of how Delta is addressing a lot of those issues that plague data lakes, in terms of performance, in terms of data management, and like real-time type operations. So Delta, in summary, it's going to be a core component of the Lakehouse. It's like the fundamental transactional layer that it's built on. From a Databricks perspective, there are different formats that are available. Like there is Apache Iceberg, which I know has picked up a lot of steam, and then there's also Hoodie from Uber. So like multiple formats exist, but Delta is one that Databricks has invested a lot of time into developing, and like there are lots and lots of improvements that are being made and optimizations being built on top of the Delta format. So I definitely encourage everybody to check it out if you get a chance. And because it's compatible with Apache Spark, there's very little harm in trying it, right? If you're using Parquet, you can use Delta almost interchangeably. I don't have the exact command in the slide here, but you can convert back and forth between the two with ease. Okay, so getting back on track here. So yes, core component of the Lakehouse architecture. It guarantees that consistency because it has that ACID compliant behavior. And I guess I'll mention in terms of the like the multiple users and the read-write capabilities. So Delta leverages something called like optimistic concurrency. So if you have multiple people reading from or trying to write data, let's say, to the same file, if the data doesn't is unchanged by one user, it'll the transformation will be added seamlessly. But if there is a conflict, it's essentially just a race, and whoever gets there first will win. And if it doesn't work, then you'll just throw an error and you'll try again later, or your data will be quarantined, like as a bad record that you can go and you can check back later to either fix the issue or rewrite whatever your transformation was. And so it offers like a robust data store, and it's designed to work with Apache Spark. Like data is being collected at in an enormous rate. Like everybody, like there's so much data being collected, and it's very beneficial to have like big data processing, in your toolkit, so you can learn how to work with these gigabyte, terabyte, petabyte size files. I've never worked with any petabyte size files before, but it exists. Okay, so so we talked about the Delta, so I'm going to talk about the components of what makes like a Delta Lake. And so it's like the architecture of the storage layer, which I spoke about, but then I'll talk about Delta Engine. And Delta Engine, just to kind of clear up some of the terminology, Delta Engine is just like the list of features that are available on the Delta format in terms of optimizations, as well as any of the Photon execution engine that I'll mention in a bit here. So, okay, so to talk about architecture, I guess I can't really go back, but in that kind of like building the Lakehouse design, one of the components was the architecture, and this is not super fancy or anything. It's just like a medallion style approach to how you manage your data. But this is a common pattern that we see being picked up all over the place, where you'd have some kind of raw data ingestion, either in its raw format. Either in its raw format. You can transform it or enrich it to like a silver level table, right? And so these can be separated by containers, maybe like within your data lake or something. And so you can have like your filtered, cleaned, augmented data for your silver level tables. And then when you have either like a data product that you want to serve out, could be for data science use cases. I've seen a lot of data scientists work off of silver tables and like write back features to new silver tables or what have you, right? And they're kind of like working in that area of the data lake. But there are definitely gold tables that you want to leverage, like maybe some kind of finance data that you want to enrich your model with, right? So you can pull that data into like your silver level processing, and then write it back to a gold level table for maybe some reporting capabilities. There are lots of ways you can organize. This is just like a quickie high level overview. But the key here is that you have like a one-way data quality movement throughout your data lake, and you can manage this through whatever your organization's data ops process is. And you want to have like a single unified system that is reliable and up to date. It's kind of like an elusive single source of truth, right? That a lot of people or a lot of organizations want to base their decisions off of. Is it feasible, to have that single source of truth? I mean, theoretically, yes, but like data is messy, so there's obviously like exceptions all over the place, but if we can really try to maintain this type of approach or this type of architecture, for your data pipelines, it will really improve the way that the data teams interact with each other, and how different business decisions can be made off of trusted and reliable data. Okay, yeah, and so I talked about what I mean by the Delta storage layer is, so now we have any of the data that can be structured or have some kind of schema applied to it. It has this transactional metadata layer sitting on top of the data lake. So here we have all of our unstructured data being loaded to the data lake, and then you have wherever possible, you have the Delta format being leveraged for structure, reliability, and different performance optimizations. And so the idea is that you'll have, one place really to build your streaming analytics workflows, your BI workflows, and your data science and ML workflows. So I mentioned BI reporting off the data lake. I'm pretty sure I don't know how new this is. I only know of Starburst really and SQL Analytics from Databricks, but building BI reporting dashboards off data lake, I would say is relatively new because of those performance issues that we mentioned before. So I'm just going to give you just a high-level overview of SQL Analytics on Databricks before going into a little bit of a demo. So because we have this Lakehouse platform, we've seen how we can ingest our data, we can enrich it, maybe use the Delta format to apply that structure. But now, how are we actually going to do that BI and reporting? So we want you have I'd say primarily data analysts or whoever is in the company building the reports. They want to be able to make business or actionable insights, from a variety of different departments, right? And you don't want that data kind of siloed. And so what Databricks does is all those Delta tables or tables just in general that are available within the data lake will also be available within the SQL Analytics workspace within the Databricks platform. And it just provides a lot more visibility in terms of what people are doing and how both the data engineers or who is ever dealing with that data governance can grant access to a reporting or a specific function, depending on how people organize their groups and access control. So I know this image is kind of a little bit small, but the idea is that it's a SQL native user interface. So you'll have access to those tables, but then you'll have you can just write SQL queries that are or that have Spark. It's using the Catalyst Spark's what was the word? The Catalyst optimizer, to transform your SQL queries into resilient distributed data set type queries, right? But you can just access your data just with the SQL language. And then the ability to to view your data either for ad hoc queries or different visualizations within the editor itself. There's also the capability to do alerting, either for data quality related things. If you're working on some kind of data processing pipeline, you want to write some alerts to if the data is outside of a specific threshold or something, or maybe you're building some kind of dashboard for sales forecasting and you're looking at, demand pricing or something. There's different alerting you can do in here. And then the ability to create those dashboards kind of on the fly within the platform itself is really convenient. So yes, you can do all of this within the Databricks platform, but there's also within the I haven't mentioned it yet. Kind of, I should have maybe restructured these slides a little bit, but within the SQL Analytics workspace, you'll have these SQL endpoints that you can then connect your BI tools to, right? So if you don't want to create a dashboard just within the Databricks platform itself, you can always connect things like Tableau or Power BI or whatever. And theoretically, we'd have a lot of the queries being optimized so you don't have those latency issues. I'll talk a little bit about the Delt Engine in a second here. Actually, sorry, the next slide here. So how do we enable those? How do we enable those that BI reporting, and how do we handle the concurrency and latency issues, right? So how do we get the advantages of the data warehouse on our data lake? And so the answer is Delt Engine, right? And like I mentioned before, just like the accumulation of features. So when we talk about the Delt Engine, some of the things that Spark 3.0 will give, as well as the Delta format. So you'll have file management optimizations, right? So that's kind of like the compaction that I mentioned before. You'll have a caching layer, right? So that's to help with different I/O. And then you'll have dynamic file pruning, right? That's like having the column level statistics. And so you can kind of filter through your data a lot easier. And then the adaptive query execution, so you don't have to manually configure clusters to be optimized for reading whatever query you do. It adapts in real time. So let's talk about the dimensions of performance. So I guess the thing to point out here is that performance doesn't have, well, yeah, I don't know, like performance, you can add all these into one metric, I suppose, but generally when you think of performance, you talk about three things. You talk about concurrency, right? So how many users or queries can the system support at the same time? You talk about latency. That's how fast the system can respond to a query. And then you talk about throughput. So that is for a given query, how much data can that system process per second or within a given time frame. And so let's kind of talk about each of these and how they are solved. So concurrency. So we have our data lake. We have a lot of users, and so a key thing to talk about in terms of Spark. I'm not sure how familiar the audience is, but you have that decoupled storage and compute architecture, right? So you have a number of users, and you want to provision a cluster that will allow them to access the data, right, and do whatever they want to do. And so, yeah, so you need that cluster for analytics or whatever, and that cluster is ephemeral. It connects to the data lake and pulls data on demand. Okay, so now what happens when you have a lot of users, or the load increases somehow? It can be problematic when you have this MPP data warehouse where you have that coupled storage and compute, but with the Lakehouse architecture, it's easy to just provision another cluster to handle the workload and deal with that kind of concurrency type problem. You can just provision more compute, and that's really the benefit of the cloud, right? Like the elastic compute. If you need more compute, you can just pay for it. But I guess the issue is that how do you now manage these clusters, right? Like, you might have like IT admins dealing with creating those clusters. Who are the different cluster policies, right? Like who can attach to what cluster, what data table access control list is associated with a specific cluster, right? And so this can cause a problem. And so the solution is this thing we call the SQL Endpoint. And what this is doing is it's allowing multiple users to connect to the SQL endpoint, and it will decide, it will automatically launch new clusters to handle the load. And so the SQL endpoint can either be used by users writing the queries, right, like within the interface itself, or it could be maybe one, you can set up one like dedicated for specifically BI and reporting, right, where you have a JDBC connection to a SQL endpoint, and now you can leverage some of the Delt Engine for your queries and dashboarding on the data lake. Okay, so yeah, automatic scaling. Yeah, and the great thing is that now, so it all launches new clusters, but also shuts down the clusters, right? And if there's a problem, it can do the auto restart when needed. So now we can talk about latency. So it's not just how fast the system responds, but it's really the latency observed or experienced by the user, right? And so let's talk a little about how we've managed like the BI protocol. So let's walk through the steps of what happens when you want to make a query against like a Databricks server. So you say, yes, I'm going to run a specific query, whatever. So it sends that message to the Databricks server. And now Databricks server replies back with a query ID and says, yes, here's my query ID. I'm waiting. I mean, like, this was definitely odd to me when I first saw this, but I think it does it in this manner to handle the variability in the amount of queries that can be run against a specific server, right? Like you might have a query that can be done within 5 seconds or something that might take a day, right? So it immediately replies back with a query ID. And now we can reply and say, hey, is my query complete yet? And now we can say, yes, the query is complete. And you say, please give me my data. Here you go. That's kind of how this BI protocol is working. It may feel a bit wordy, but it definitely handles the diversity of queries that could be thrown at the system, right? And so, but now you have this issue, right? So like, if you are trying to query a server spread out around the globe, you have like that transit time, right? And then you have the compounding of latency, which could make your BI system unusable to some extent, right? I mean, this is just an example, but like 300 milliseconds for like a query that will do nothing, right? That's just on the actual protocol wait time. You'll have 2 seconds, right? And so we want to try to avoid that. And so for short queries, we have like an optimized BI protocol. So the Databricks server will wait for a few, I don't know the exact time, but it'll wait a certain amount to see or to gauge what that query is doing. And if it is a short query, then it will immediately return the result versus having this back and forth chatty dialogue. And so this optimized BI protocol is one of the things that will help with that latency issue. Okay, so now we can talk about throughput. So throughput is for a given query, how much data can that system process, right? And so when we talk about the life of a query, so we have our BI tool, we have SQL Endpoint, and now these are all the components. Remember I said like it was like a list of features. So here are all the features that make up the Delt Engine. So one of the key goals of Databricks is, is like really to make things simple. And so, we try to hide some of the stuff like around the optimizer, execution engine, caching, and so on. And we just package it up into something that we call Delt Engine. But let's just talk about kind of like what is happening behind the scenes. And I'll just kind of briefly go through them in each stage here. So the first is the optimizer. And so this this is just extending the Spark's cost-based optimizer and some of the adaptive query execution for Spark 3.0. Specifically, looking at both compile time and runtime stats and optimizing a query before actually translating that into resilient distributed dataset code. Now we have the execution engine. So now this is the thing that's it's proprietary to Databricks. So they essentially rewrote Spark from scratch in C++, where they have this vectorized execution engine, which they call Photon. And so this is allowing optimized performance. Like here's I'm not like a performance buff or anything like that, but here are like the benchmark stats versus kind of like Spark, the JVM, or like the Presto example, and so it's really showing like a certain like I think almost 10x performance in terms of JVM based execution. Yeah, like definitely if you're interested in this a little bit more, you can go and look at some of like the data and AI talks and just like look for stuff around Photon. But this vectorized execution is really important. So now we have the caching layer, and so most query workloads, they have these concentrated hot data, right? So you're reading from the data lakes, and the throughput to cloud object storage is not as high as the local disk system. Right, and so it's the format is actually transcoded into a faster file format that Photon then reads, right? And so by the time Photon is actually reading it, it's not actually reading Parquet anymore, but just an optimized ephemeral format. Okay, so yeah, so there's a caching layer to handle that kind of I/O. And then the way that the data is actually laid out, right? So how your data is partitioned, like we mentioned with the Delta log before, you have that data skipping feature, which like I think is probably like the most referenced or like highly used one, is that you have like things like column stats, like minimum and maximum. So if you write a query, right, select star from events where year is 2020 and UID is whatever, you don't, because you have this transaction, you don't have to go searching through all the different files, right? You can just say, oh yes, because I can filter by my column statistics, I can just go and find this specific file here. So that in general is kind of like the life of the query. And so this is really what enables SQL Analytics on Databricks to get this like really great price performance ratio. So, we're really getting a lot of things. Like, so we're getting a platform where we can handle all the different use cases, streaming, BI, data science, ML, or whatever. That's not all that exists in the world. But then you have a high performance query engine. You have Delta, which is the structured transactional layer. And then you have all this sitting on top of cheap cloud storage, ADLS Gen 2, say. Yeah, that kind of like builds the actual Lakehouse. So that's kind of what I have for presentation. Hopefully that gave everybody a good idea of what we mean when we refer to Lakehouse. I mean, it's recorded, so you can always go back and watch it. So let's go into a demo. So let's see here. Okay. I'm going to stop sharing for a second, if that's all right. I have a pretty wild screen set up here. So let me just move this back. Give me 2 seconds here. Okay, share content, screen 1. Okay, is that, can you guys see my screen, Renata?
Yeah, we can see it.
Okay, amazing. Okay, so let's see. So let's talk about. Okay, so let's talk about. So we talked about this Lakehouse platform. Okay, but now how are we going to bring these data teams together? So I'm going to walk through like our Lakehouse demo. Not in real time. I'm just going to kind of like walk through a few notebooks around data engineering, data science, and SQL Analytics. And I'll show you kind of how we envision all the different personas working on a unified platform, right? Where you're looking at consistent versions of the data set, you're managing control, the data engineers building the data pipelines, preparing the data for analytics, the data scientist is training a model, moving it to production, and either creating some kind of model endpoint, right, to run predictions against, or creating some kind of data product, essentially, right, that somebody can use or visualize. And then the data analyst persona, where you can actually do those real-time ad hoc queries, really get down into like the nitty-gritty details of your data set and leverage the same data that the data engineer was building and the data scientist was creating as well. So the demo that I'm going to go through is just a predictive maintenance one related to loss of revenue caused by downtime and wind turbine failures. So the idea is that you want to proactively identify and repair wind turbines to increase your energy production and reduce your loss in revenue. And so the idea is that we want to ingest the data from a bunch of sensors on your turbine. You want to build a predictive model, and you want to build a dashboard that you can then report back and check the status. So I won't have time to go in these Lakehouse patterns, but I'll just kind of go through the demo because I want to leave maybe like a second or two for questions. Okay, so I'm here. I'm in the Databricks Workspace. I'm not sure if everybody is familiar with it, but for those of you who are familiar with like Jupyter-style notebooks, it's similar, right? It supports languages like Python, Scala, R, SQL, and you're able to interchange those languages between the cells. You can see here, like on the left-hand side, I have my workspace where I've managed my different notebooks and files. Projects where I control like my version control if I want to sync it to GitHub or Azure DevOps, what have you. My data tab, cluster management, automated jobs, and models. We won't really touch on all of them, but that's kind of like what's happening here. And you can see at the top, I've named this data engineer, and I've attached myself to a specific cluster. And just to show you kind of like creating clusters on Databricks is quite easy. You can create like single node, small, medium, large type clusters. You can look at kind of specifics around that. You create a name, you can create pools, create a specific version, or pick a specific Databricks runtime, whether you want to have a lot of the ML libraries installed, long-term support. Spark 3.0 is not available on anything like 7 and higher. So you can do things like auto scaling and that kind of stuff. But I already have one set up, so let's go back. Okay. So let's go through here. So this is our predictive maintenance notebook. This is from the view of the data engineer. So we're ingesting our streaming data from our wind turbine sensors. We're getting it into the raw data. Is my screen big enough? I don't know. Maybe I'll make this a little bit bigger. So you're ingesting it into the raw layer, into like raw JSON. Now you want to create your silver level tables, right? So that would be like your parsed or enriched data. And then your like gold level tables. So if you have maybe like your predictive column or different types of dashboarding type tables could go to gold. I'm not going to discuss really the ML aspect of it today. I mainly just want to focus on data management, Delta, the architecture, and then how to actually build a dashboard on the platform. So so the data set's containing of vibration readings coming off the sensors, the wind turbines. We're going to run a gradient boosted tree classification algorithm to predict either a damaged turbine, a 1, or a healthy turbine, which is a 0. Okay, so let's talk about the bronze layer. I'm not going to go into too much detail, but it's easy to read streams within Spark. It's just a Spark read stream. This cloud files format is allowed from something from the autoloader. You can Google like a Databricks autoloader to see what that's about, but we're specifying like the format we're reading where the data is being loaded from. So it's coming from this data directory, demo resources, turbine incoming data. And now we want to write our stream. So we're going to take that stream and we're going to write it to our turbine bronze table. And so now we can run a specific, see, now this is kind of like this magic command allows you to run SQL within a different cell of your notebook. So now we can select star from our turbine bronze table that we just created, right? This table here. And we can see that we have a key value style data set, right? And this is being JSON. And all this AN3, AN4 stuff, these are all the different sensors and the sensor reading, right? Separated by a column. So we want to turn this into something usable, something tabular. I will note, I think like in terms of like the photon execution, there are some limitations in terms of how nested the data is. So generally try to default to like more of like a flat data structure, just tabular type data if possible. But so now we have this, we're going to parse this out, right? So we're reading this from our bronze, right? And we're going to parse it out and we're going to create our parse data in our silver table. So now we are going to specify a schema, right? To give that structure to our data, look at our different types, all the different columns that we have, and the timestamp. We're going to read in our JSON data, apply our schema, and we're going to write write that stream to a Delta format. And that's really it's relatively easy. Like all you have to do is specify the format, and it should work seamlessly interchangeable with like Parquet and so on. And then we're going to write that to our silver table, right? And so you can see like different types of the input versus processing rate of your stream or your batch duration. You can kind of see that kind of streaming workflow. I'm not going to run this right now, but this would be available if you ran it in this notebook. So now when we select, let me show you. So now if I click on the data tab over here, the data tab, I looked at, let me see, turbine. So if I look at this demo turbine database, you can see that I have all these tables. This is already pre-run, so all these tables are already created, but you can see that I have like my silver, my bronze layer in here. And if I click on the silver, I already have it open. You can kind of just get like a little snapshot of your table, what the schema is, and maybe a different sample data, as well as like the history. Hopefully this runs. You could also get the history around it, and you can take a look and see like which notebook generated that data. Sorry, maybe I timed out of this, but this might not load up here. So, but you can get a history of your data set, username, who ran it, different table properties. Are there specific things? So here we're running like just how I mentioned. There's like that specific features in Delta that you can specify in your Spark config, right around like auto optimization, auto compaction, and auto optimize, right? So these are kind of just key things that I wanted to mention. Okay, so now going back here, so now we can query our data, and now we have this tabular data format where we have all of our sensor data. But now in order to build our predictive model, we're going to need our target variable. So we're going to create a gold table, and we're going to add our label. We're going to add our label to our data set, and we're going to join. We're going to join our turbine status, left join to our stream using the delta. And now when we query our table, now we have our status at the end here, and we're going to use this data set, time, sensor, and status to build our model. Oh yeah, and the last thing that I wanted to mention is that so using just SQL commands, you can then grant access to a specific user ID or specific groups, right? And you can manage that either through programmatically through the API, or you can do it through the admin console in Databricks. Here you have admin settings. Okay, so now let's move on to the data scientist persona, right? So they want to take that data that's been ingested properly and built out by the data engineer, and now they want to take that and build a model, right? So, but what can you do? You can use the notebooks for a lot of things. You can use it for like production jobs that would show up here, or you could use it for like just data exploration, right? So you can run some summary statistics on your data set, you know, just basic stats. Or you could look at different feature correlation related things and create plots within the notebook itself. And, you know, you can use like the display function to have like that interactive plot feature within the notebook itself. Or you could use your favorite tool, Plotly, Matplotlib, ggplot, whatever. So, and then you can just have those things kind of like built up in here. So here's like a correlation pair plot. And then, yeah, so now I want to say MLflow, maybe I'll do another talk at a later date, but like MLflow is what we typically use to deal with like the model tracking API, as well as the model management and governance. So just a quickie high level here, we're setting up our train test split. We're setting a context manager here to do like our MLflow start run. And then we're setting an auto log feature. So this is going to understand what are the different parameters that are used in model building, as well as any of the metrics that you want to log. Well, I think you have to specify the metrics. Oh yeah, so down here you'll have like specifically what metrics you want to look at. MLflow.log metric. I want to log my precision metric. I want to log my F1 score and my recall. Right, because this is a classification model. So we're looking at our true positives and you know, true negatives and all that kind of stuff. Okay, so we want to log the model as well. We're gonna create a confusion matrix, and so like this is kind of what we would get from that MLflow run. We'd have like a term on dimension prediction, F1 score of 0.85, and then we could do things like register that model in the model registry. Yeah, sorry, we can add specific tags. We can do like a lot of different things, kind of like just with the MLflow API itself. Looking at versions or transition, like here we've set up like MLflow client, right? And so now we want to transition model version stage. And so this will move things like if you have a data scientist who's building some kind of prototype model, they might have it in staging. It might need to be reviewed by, let's say, some kind of product owner or some kind of some kind of admin, or maybe like a senior data scientist or whoever, and then they would be able to either programmatically move it to production or use the MLflow models API or UI within Databricks itself. So here we have our models, and I created this one here, like turbine failure model. You see I have like version 2, and now I have like a serving ready. So if I click on the model itself, you see that I have version 1, version 2, and if I look at the serving, I can either put in a request here just to kind of like test out like my model response, or if I wanted to build it into some kind of API call or use a specifically scoring function against this model URL, I can do that, and that's kind of all tracked within here. So your model is ready for production. You can kind of have one place to manage this model, both the data engineering and the data science. So now let's talk about the SQL Analytics dashboard. Oops. Okay, hopefully this doesn't fail because I logged out. Okay, yeah. Okay, so this is an example of what a dashboard could look like within SQL Analytics. And so the one thing that I'll note down here is that on this kind of 9-dot square thing here, you have the workspace where you would do like the data engineering or the data science, but then you have the SQL Analytics editor and dashboarding tool. And so this is where we jump in. And so this, you can see it looks a bit different, right? You have dashboards, you have queries, you have alerts and endpoints. So similar to workspaces, I'm just going to quickly show you the endpoints. So like here is the, this is just a shared photon endpoint. The one thing that I'll mention here is that the photon is enabled. So it's something that you have to enable specifically for an endpoint if you need that processing capability. But then it also provides connection details, right? Like if you want to actually connect to your BI reporting tool of choice, right? You can use this JDBC URL. We have queries. So if I want to run a query, you can see on this endpoint, I have access to the same tables that I had within my Databricks Workspace. So here I have my bronze, silver, and gold tables. You can be a little bit more fancy and control who can see what, but for the demo purposes, we have admin access or whatever against all of these. And so you can write, so this might not work, but select, so you have like this autocomplete, select star from demo turbine dot turbine power prediction, right? And so you can run these types of queries. Hopefully this will run. I don't know. I didn't have this up and running. Okay, yeah, so it did. So like this is an example of sorry, I guess this isn't exactly the model we were building, but this shows like the hours, the min, max, and the actual prediction. This is actually for the power consumption, but what I wanted to highlight here is that you can just run these kind of ad hoc queries against the tables, but then you can also create a visualization, right? So if I wanted to choose like your X column is maybe like time, and your Y column is maybe the max, minimum, prediction, and you want to plot a line chart or something like that, right? You can save this as a visualization, and you can add it to a specific dashboard here within SQL Analytics, right? So I can go to Turbine. I have like a Turbine demo one here, but if I just go up to my dashboards over here, because I already have it added, if I go to my favorites, Turbine demo predictions. So here's that demo that I was looking at. So we have one damaged turbine, right? And we have 501 healthy turbines. We're looking at the energy produced. We can see like, you can customize this dashboard just based on those queries and adding them to a visualization dashboard. And so I think I'll stop there. Hopefully it's enough. But the key takeaway really is that you're enabling all the different personas within your data team to work off of the same data process with reliable, optimized, or reliable structured data with the Delta Engine optimizations that will power both your ETL workloads as well as your BI and reporting workloads as well.